Hi, it's Sam. In this video, we're going to learn how to play back audio files using Gen, and in the process, we'll learn about how to use Gen. So I'm just going to start off by making a Gen subpatch, typing in Gen, then a tilde. And actually, let's give this a title. I'm going to do @t, which is short for title, and call this, let's say, file playback. Now if I double click on it and open it, you'll see it's called file playback here. But I want to go over a few details about using Gen. So the first thing about Gen is that all operations are synchronous. And what that means is that typically in Macs, you have to think about the order that our code is executed. So for example, we'll use triggers so that code will execute in a certain order. But in Gen, everything happens at the same time. So that makes the code a little bit easier to manage. Number two is that the code will run continuously while the audio is on. So if your audio is on, like when you turn on the audio with an EasyDAC, for instance, the code will be running continuously, just like any other audio signal in Macs. It's always running when the audio is on. Three is that all numbers are floating points. So even if something's expressed as an integer, like 1 or 4, whatever it might be, it's all converted internally into a floating point. And now we typically will calculate time in samples. So 1 second would be whatever the sampling rate is in samples. So for example, like 44,100 samples would be 1 second if your sampling rate's 44,100. And there is a useful operator we call the objects, or the, I guess, functions, whatever it might be. We call them operators in Gen, and there's an ms to samps operator that can help us convert from milliseconds to samples, which is useful. So these are some of the things to keep in mind when working with Gen. Let's first make a buffer that we're going to refer to within Gen. And let's just call it SF for sound file. And we can also check the current sampling rate by using DSP state. The only caveat is that, let's see, I think it's this, yeah, here we go. Current sampling rate is the second outlet. The caveat here being that you have to turn on audio to get the updated sampling rate. So I think my sampling rate's actually 48,000. So once I turn the audio on, now it's correctly reflecting the sampling rate. So now let's open up, and you'll see we have just a very simple patch. We have 2 inlets, in 1 and in 2. They're adding together and then going out of out 1. So the first thing I want to do is to show you how to refer to a buffer. So we're just going to make a buffer with the same name, SF. And now we can access this buffer data inside of this Gen patch because it shares the same name as the buffer outside of the patch. Now to read the sound file, we're going to use the peek operator, which reads values from a data or buffer object. And we need to give this some arguments. First will be SF, which is the name of the buffer. 2, so there's 2 channels. Now there are some additional arguments we're going to give it. First is interp, which is the interpolation mode. And we can just put this on linear. This just sets the quality of the interpolation. Basically, the importance of interpolation in this context, if we're going to be reading through samples. So we're going to tell peak to read back sample 0, then sample 1, then sample 2. Now, if we were to give peak a sample number that's between 2 indices, so for example, index 0.5, that's not a valid index. So it needs to draw a line between the sample 0 and sample 1. And this is how it does that with interpolation. So if you don't have interpolation and you send some floating point value index between 0 and 1 or between 1 and 2 or whatever it might be, then you'll get artifacts. So we want to avoid that by adding interpolation. Let's also add the bound mode, which is how it will handle out of range indices. So if you were to send it like a -1 or send it an indice that is past the buffer length, we can use wrap so that it wraps it back into the range. And then lastly, channel mode is how it handles invalid channel indices. So we can use wrap as well for this, which if there is a mono file, will make it so that it will output the channel 1 from both channel 1 and channel 2. Whereas if it's stereo, then it will correctly have the left and right channel output. So this way we don't have to worry about rerouting the channels. So we're going to send the output to out 1 and out 2. This will be our left and right signal. But now we need a way of reading through the buffer. So peak takes the sample index that it should read. And there is a counter object which will count based on the sampling rate. So it adds whatever number you send into the leftmost inlet is how much it adds to the counter per sample. So we can just send a 1 for right now. The middle inlet takes a non-zero value to reset the counter. And then the rightmost inlet is the count limit. So 0 means no limit, but we want this to only count up to the size of the buffer. And we can get that size by using the dim or dimension operator, which gives us the length of a data or buffer object. So we'll put in SF because that's our buffer. Now I can read from 0 up until the length of the buffer. And the counter will output the count from the leftmost outlet. And that's what we want to put into peak. But it's like kind of an extra precaution. Let's wrap this value between 0 and the dimensions just in case, because later on we're going to make some changes to this. So to recap, we are taking the counter and every sample that the patch is running, the audio is running, it will add 1 to the current count. It will count up to the size of the buffer and then start back at 0 again. So this will let us loop through the buffer. And I'm using this wrap to wrap between 0 and the size of the buffer in case we go out of bounds with some of the code we're going to be adding later. And we're using peak to refer to the sound file buffer. We're outputting 2 channels. We're using interpolation because later on we're going to add some code that'll let us count in fractional samples, which if we do that could create some artifacts. We're keeping the bound mode in wrap in case we send this some invalid indices, and we're keeping channel mode in wrap so that it can handle both mono and stereo files correctly. If we want kind of an on-off feature for the sound file playback, we can do that with the middle inlet, which resets the count. So we can create something called a param, which, as it says here, is an externally modifiable named parameter. Let's call this on-off, and let's set it to 0 by default, with a minimum value of 0 and a maximum value of 1. And then what we want to do is when it is 0, we want the counter to not be running. And when it's 1, we want it to be running. So since a non-zero value resets it, we want to check, I'm going to use expression here. We're going to check if on-off equals 0. So if it's 0, we're going to send out a 1. If it's a 1, we're going to send out 0. And the nice thing about Gen as well is I can use the param as part of expressions like this. I could also do something like this. So now I could take a value and multiply it by whatever on-off is set to. Now from outside the patch, I can use on-off as well. So I'm just going to create a message box that's on-off with a $1. And you'll just use a trigger to turn it on and off. If you right-click on Gen, you can also have it as a attribute object. So let's just add live gain. And now we're also going to need to put something into the buffer. Okay, turn on audio. And then let's turn it on. And that turned it off. Otherwise, it'll just loop continuously if you just turn it on. Okay, so now we have it playing back. Let's add a little bit more capabilities to this. First thing we can do is add speed. So right now it's just running at normal playback, normal pitch, normal speed. But what if we've changed this value? Let's make a speed parameter. Let's have it default to 1, but have a minimum of -2, so we can go backwards, and up to +2, oops, max 2. Now let's change this. We can just plug speed directly into here. Now let's see how this changes it. Let's try adding the speed now. Now, because we added in this wrap and the bound mode, we're taking care of any contingencies that might go wrong, because when we do -2, we're now counting backwards. So we're keeping it within the correct range, though, so that it's not going out of bounds and then kind of reading nonsense. There's one wrinkle here that we have to fix, which is something you might not realize until you start using audio files with different sampling rates. And let's take a listen to this. I have this Eroica file. Okay, now let's put it into the buffer and play this back. All of a sudden, the pitch is not correct. And that's because we have a different sampling rate of the file and from our project or our Mac software. So it's playing it back at a different rate because counter is counting at the rate based on the sampling rate. So to fix this, we just need to take another parameter that's going to get the sampling rate of the file. We'll just make it a default of 44,100. I don't need to have the min and max, so in this case I won't put it. And then make another expression. It's going to be the sampling rate divided by the sample rate of the project. And this is kind of a constant operator here. This is something I didn't have to declare. It's just part of gen. This is just the sampling rate of max. So we're going to take that and multiply it by speed. So once we have this ratio, multiply that by speed, then we can get the correct playback rate. So let's grab the sample rate of the file. To do that, we'll use the info tilde object with the name of the buffer. And we'll bang it when the buffer is loaded with a sound file. And then we'll send that sample rate, which comes out of the first outlet, to gen. So let's see if this works correctly now. Okay, now we've got the correct playback. So this is 44,100, which is set into our patch. Now another consideration is debugging, which is a little bit tricky in Gen. So you can't print to the console, you can't probe the wires. So really the best way to debug is to create some extra outlets and then check the values. So for example, I can take this counter and put this into the third outlet and then I usually use something like number tilde. Sometimes it's useful to visualize as a scope. Especially if I'm working with a phaser, for instance, I want to be able to see how the phaser is moving. So let's see this, for instance. So you can see the count going up. You'll notice that it's actually fractional, and it can be hard to hear. It depends on the material. But if I change if I change the interpolation to none, you can start to hear some artifacts. The quality is not as good. Kind of sounds like noise is added to it. But when I change the interpolation back to linear, that goes away. So that's why interpolation is important to add. And linear you can usually get away with, but if you want something better, you can use a different interpolation, just as a CPU trade-off. So I hope you found this video useful. In the next tutorial, we're going to be looking at other ways we can start to manipulate the buffer to play back the sound file in different ways. Please let me know if you have any questions or need any clarifications. Otherwise, until next time, class is dismissed.